Okay, welcome to this lesson on quadratic functions. I've already given our lesson on the discriminant. If you haven't seen it, you better go and watch that one first. This is part 2. So what we found in the first part is that the discriminant, b squared minus 4ac, can help categorize our quadratic functions into 3 groups. Ones that have 2 solutions or real and unequal roots. A group that have got only one solution or real and equal roots, and a group that have got no solutions where the roots are not real. And that all depends on the value of the discriminant, whether it's greater than 0, equal to 0, or less than 0. So that's a wee reminder. If you've got that written down somewhere, it's a big help. So what we're going to do in these examples is that we're going to find ourselves solving a little bit of problems where instead of working out the nature of the roots, we're going to be told the nature of the roots and we're kind of working back the way. So let's have a look at these examples here. It says find the value or values of k so that these quadratic equations have equal roots. So this time we're told the nature, but what we're trying to do is to work out what the missing coefficient is, what its value is. So we can go ahead and use the discriminant. That's what we would normally do when we're talking about roots. So anytime you see the idea of the nature of roots, we're going to use the discriminant, whether or not you can work it out. So what we've got, A is k this time, B is positive 4, and C is positive 2. Okay, so let's work out the values here. What we're saying, the discriminant, we're not trying to solve the equation, we're trying to work out the value of k. So b squared minus 4ac, we would say is, what's that, 4 squared is 16, minus 4 times a, so that's actually where we introduce the letter k. And c is 2, and we've got this expression here, 16. Negative 4 times 2 is negative 8. So we can write down negative 8k, 16 minus 8k. We can't do any more than that because we don't know the value of k. However, we do know that this quadratic equation has equal roots. Okay, so we can write down, because we know it's for equal roots, okay, for equal roots, b squared minus 4ac equals 0. And that's a fact. We're told that it's got equal roots, so we can write down that fact. So we've said that b squared minus 4ac is equal to 16 minus 8k. We've also declared that b squared minus 4ac is equal to 0. In other words, we are saying, i.e., that is, that 16 minus 8k also must have the value of 0. These two are equal in value. So we can create a new equation, 16 minus 8k equals 0. You can solve that in whatever way you want. 16 minus something is 0. It means 8k is equal to 16, which means that k is equal to 2. Okay, there's only one value of k, and that is the value that we need for the equation to have equal roots. In other words, one solution. Let's have a look at the second one here. You notice that k is in the coefficient of the x term this time. So if we write down a is equal to 3, k is equal to, b is equal to k, and c is equal to 3, then we can say, we're checking the discriminant, b squared is equal to 4ac, and that is equal to, well, we've got k squared minus 4 times 3 times 3. Okay, so we've got k squared minus 4 3s are 12, and times 3 is 36. K squared equals 36. Well, we can't do any more with that, but we know that this equation has equal roots, so we can state for equal roots, what's true? B squared minus 4ac is equal to 0. In other words, k squared minus 36 must equal 0, i.e. k squared minus 36 equals 0. Well, look, we've got another quadratic equation to solve. Now we could use the factorise it. We could find the difference of two squares. But if you are confident with the fact that that's a square number, if you add 36 to both sides, k squared equals 36. Find the square root of both sides, as long as you remember that the square root of 36 is plus or minus 6. Okay, you could have we could have done k minus 6, k plus 6, and found the difference of two squares and solved it that way. But if you can solve it just with that form there, I think it's easier in these circumstances. Okay, one last one. Let's have a look at x squared plus 8x plus k equals 0. So basically there's examples with the k in different positions. If you want to have a go at it, pause the video and think, have I learnt enough about it to do it myself? Okay. So in this case here, A is 1, B is 8, and C is k. So we can say that B squared minus 4ac is equal to 8 squared is 64 minus 4 times A is 1, and we've got k there. So we've got 64 minus 4k. That's as far as we can go. But we know that this equation has equal roots, so we write it out. We don't just assume that somebody knows it's in our head. For equal roots, what's true? B squared minus 4ac is equal to 0. So we're saying that b squared minus 4ac is 64 minus 4k. We're also saying that it's 0. So we can say i.e. 64 minus 4k is equal to 0. So 4k must be 64 itself, because 64 minus 64 equals 0. So 4k is 64. Divide by 4, and we end up with, what's that, 16. Yeah, k is 16. So that's how we can use the discriminant and the nature of the roots to find unknown values. I'll give you one more example. Find the range of values of k, the range of values of k, so that this quadratic equation has no real roots. So a range of values suggests it's an inequality, that k is going to be greater than a number, or k is going to be less than a number, rather than just being one or maybe two solutions. The fact that k does not equal 0 here, that's not going to affect us. We just have to include that as a descriptor, because if k were 0, then we wouldn't have an x squared term, and we'd just have the x 6x minus 2 equals 0. So k doesn't equal 0 tells us that it is a quadratic formula. We're not going to use that bit of information though. It's just a disclaimer. So what we're going to do here, let's, as normal, a equals k, b equals 6, c equals negative 2, and we can go ahead and go b squared minus 4ac is equal to, b squared is 6, that's 6 squared is 36, minus 4 times a is k, and c is negative 2. Watch that a negative term in there. That alerts me to the fact that negative 4 times negative 2 is positive 8, and we've got positive 8k. 36 plus 8k. Now, the nature here is that there's no real roots, and we know, according to our kind of big table of everything that we started the lesson with, we can say that for no real roots, b squared minus 4ac is less than 0. So what we're saying is that b squared minus 4ac is equal to this expression here, and we're saying that that is less than 0. So in other words, we can say that 36 plus 8k is less than 0. And if we take 36 away from both sides, we can say that 8k is less than negative 36. We can divide both sides by 8, and we end up with k is less than, well, negative 36 divided by 8 doesn't work as a whole number, so if we simplify, divide through by 4, we get 9 over 2. Okay? So, what we've done is we've solved this problem here that says find the range of values of k so that this quadratic equation has no real roots. We have used the discriminant to come up with an expression with numbers and the letter k. We've declared that for no real roots the discriminant has to be less than 0, and when we solve the inequality that we make, we find that k is less than -9/2, and that's the range of values, basically from -9/2 down to -infinity effectively. So that's our answer. Okay, so I hope that's been helpful. A wee bit of problem solving using the discriminant. You can go and practice some like that.